Welcome to Unreal Gems. In this video, we are going to take a look at translucency in Unreal Engine. We will create a glass material and also a skin material that uses subsurface scattering to get those realistic skin effects. Okay, so when we are done with more common effects like we have seen before and more common texture maps, we are now going to take a look at translucency, which is a more advanced effect, but it comes up quite a lot in glass, water, skin, so on and so forth. Some materials do not absorb light completely or do not reflect light completely, and in those materials, light can travel in a straight line, so with no dispersion, or they deviate its direction, the light's direction, randomly, which is called dispersion. So in the left we have the no dispersion material, and on the right we have the material with dispersion, which in this case is skin. So here light is deviated, but it is not dispersed, but here it is dispersed randomly. That's why we cannot see behind the object. So these two types of materials are called translucent materials. Okay, so the first type, which is simpler, has a refraction, which is an effect that makes light change direction when you are switching to a different medium. So for example, when you switch from air to glass or glass to water, they have different indices of refraction. Remember Fresnel, remember the specular pin. So here the materials will have different IOR, and that means that light is going to be deviated, so the angle is going to change when it switches medium. That's why we see the reflection that is kind of weird and like rotated. That's due to this effect, the refraction effect. Okay, so in this slide you can see that we have a compendium of all of the effects that we have seen up until now. So you here have reflection, you also have refraction, you have dispersion, and also again refraction when it comes out of the glass, and when it hits the ground you have the diffuse reflection. So you have a lot of different effects here. Right now we are looking into refraction, which is the laser changing direction when it enters the liquid, and then again when it exits the glass. But this is quite curious, and I really like this photo because it has all of the effects in one, and you can see everything working together. Again, in Unreal, we are going to work with the opacity pin in the material node. When we switch to a translucent material, you are going to be able to define how translucent the material is. So in this case, if it is 0, it will be completely transparent or translucent, and if it's 1, it's going to be fully opaque, so you are not going to be able to see through. You can see here the switch from complete black to full white, and you can see how the translucency switches from one to the other. So it is quite simple, as you can see, and let's now look at some examples. Okay, so let's take a quick look at a glass material example. We can go ahead and open up the m_glass material, and you're going to see that this material makes use of the Fresnel node in Unreal Engine. We use this because the glass material is going to deviate light in a different way in its borders. So remember, at grazing angles the light is going to be more refractive. So that's what we are trying to achieve using Fresnel here. Okay, so first things first, the overall color is just the base color of the glass. In this case, we are using a simple parameter to be able to choose it in the material instance. We can make it in the color that we want. Next, we have the metallic pin, which is fed by two parameters that a lerp is going to choose between. Remember, like in the first example of Fresnel. So when we are close to the border, we are going to choose a maximum metallic parameter of 1, and when we are head on, we are choosing 0.8. We are doing the same thing with the roughness, between 0 in the extremes and 0.2 head on. Next, we have the opacity, same thing. We are going to be more transparent in the middle and less transparent on the extreme angles. So again, we connect that to the opacity pin, the roughness to the roughness pin, and last but not least, we have the last parameter that we use only with translucent materials, which is the refraction parameter. It's also going to change between the glass refraction, the glass index of refraction, which is 1.52, and the air IOR, which is 1. Remember always to select the material node, and in the material node we need to choose the blend mode as translucent, and the shading model we can keep at default lit. And last but not least, we need to take a look at the lighting mode, because this is dependent on translucent materials. We have lots of options. If we go from the top down, we are going to find the cheapest option, the volumetric non-directional, volumetric directional. It's more expensive. Next, the per vertex non-directional, per vertex directional. As we go down, they get more expensive. Surface translucency volume, which is the one that I am going to use, which is a middle ground, not too performant, but not too taxing on performance. And last but not least, we have surface forward shading, which is the most accurate one. If you combine the earlier ones with, instead of default lit and lit, you can make transparent things which only are like kind of transparent. They do not refract and they don't do anything special. But for some applications, it can be the way to go. In my case, I wanted to be physically more correct, so I'm choosing default lit translucent and surface translucency volume. There is another option that is important for translucency, which is the refraction mode. We have two refraction modes, which is index of refraction, which uses the IOR. But for example, for water, you may want to test out the pixel normal offset. So index of refraction works better for spheres, for things with changes in volume and so on and so forth, and different shapes. But for planes and things like water, you can use pixel normal offset. It can be better, but this is quite advanced. Okay, so let's take a look at the material instance and let's play a little bit with, for example, the color, and you are just going to see the crystal, the glass change color. So you can see that as I go back and forth in the color, you see it changes appearance. Let's go ahead and leave it as it was, and let's take a look at the glass now in the level. Let's go ahead and drop the material instance. You can see that the glass is refracting light in the curves more, and things are being more displaced in those extreme angles. While we look at things head on, the displacement is not so obvious and the glass is more transparent. So you can see that this material is pretty cool, and you can go ahead and tweak everything, like the refraction. You can see that it switches and it looks quite well, quite awesome. You can go up or down, and you can even choose parameters that don't make physical sense if you want to. If you are an artist, the thing that is important is having the look that you want. Same with the opacity, I can make it more opaque, less opaque. And again, remember in the middle, as you can see, here you see Fresnel working perfectly. I can go ahead and leave it as it was. And again, you can go ahead and fiddle with all of the parameters and see how it looks. But with this material, you have lots of options and it looks quite good. But now I have a cool trick that you may not know, which is the thin translucent materials. So let's go ahead and take a look at the thin translucent material version of this glass. This type of material, this type of shading model is pretty cool to create tinted glass. So in this case, we are going to have the same parameters more or less. We are not touching refraction, although we could, but we could also use Fresnel like we did before, but I'm not doing it because I think that this way is clear and you can see a more simple glass material, but you could combine what we saw before with this one and you could get like quite an advanced glass material in Unreal Engine. So we have the base color, which is the color of the glass like before, the metallic parameter, specular parameter, roughness parameter, opacity, same thing as before, and here we have the transmittance color, which is a special node that you can look for by thin translucent material output. You need to first select the thin in the shading model. After selecting the translucent blend mode, you need to select thin translucent, and there is one more step because right now thin translucent it is only compatible with surface forward shading. So you need to, instead of surface translucency volume, select surface forward shading. And with this you will be ready, you will have all of the same nodes that I have, and you are going to be able to tint the glass with the transmittance color. It's a mix between the transmittance color and the base color of the glass material. So let's go ahead and take a look at the material in action. You can see it there in the material instance, but let's go ahead and use it in our object. As you can see, it looks pretty cool. Let me real quickly adjust the camera a little bit so we can see it better. You can see that it tints the background. It has specular highlights. This in the glass is quite expensive, and again we can adjust at our pleasure the different parameters. We can make it more transparent so the transmittance color is more apparent, or the base color is more apparent. We can change colors, of course, and change the tinted glass color. We can make it blue, we can make it orange. As you can see, we can play a lot with this, and you can create really cool effects with these types of materials. Okay, so if we remember a couple of slides back, we talked about two types of translucency, the simple one and the one with dispersion, which was more complex. Well, we are now going to talk about subsurface scattering. That is the second translucency mode, in which light penetrates a surface, interacts with the inside of the surface, and then exits the surface in another point with a different angle, and obviously being scattered in the inside of the material. So in this case, you can see it happens a lot in the human skin. Well, in this case it's not human, but it doesn't matter. So we have here the ear, which is thin. The backlit ear is absorbing light, and then it's coming out this side, and we are seeing it because it hits our eyes. After being scattered, that's why we cannot see behind the ear. That's why the ear is not transparent. So again, this type of material is really important for skin, jade, marble, leaves, wax, milk, everything that allows light to enter and then exit at another point after being scattered. So you can see here, my friend, the laser, the beam of concentrated light is entering the subsurface scattering medium. So the medium is scattering light. You can see it clearly because the beam is not a beam anymore. It is being scattered, and that's what we see right here with this liquid inside this glass. So Unreal provides us with the subsurface profile type of material, which allows us to render realistic skin in Unreal Engine. So we can also do wax or jade or whatever we want. This is a technique based in screen space because it is adequate for real time, and because the effects of subsurface scattering in human skin are quite subtle. So in these cases, we only have backscattering, for example, in the ears. We are also using a thickness map, opacity map, or a scattering map. It has a lot of names, but what this map says is that if we have 0, there is no scattering, and if we have 1, there is full scattering. So in this case, remember, the ears are thin, so light may enter them, interact, scatter, and then come out, and that's why we see the red tone in the thinnest part of the ear. And again, the thickness map is telling us that this point in the ear is going to scatter light. It's going to allow light to come in, being scattered, and then come out. We see that the chin is thicker, so light is going to be absorbed, but it's not going to be allowed to come out. So that's why we have a more a darker color, and we are not seeing white here. The lips, again, take a look, they scatter a lot of light and they absorb and then scatter a lot of light, so they are almost pure white. So that is the logic behind these types of thickness maps or opacity maps to drive the subsurface profile. And again, be careful, because this is the opposite as with the simple translucency, because remember that 0 was transparent. In this case, 0 is no scattering, and 1 was opaque, which in this case 1 is full scattering. So the logic is quite the opposite as with normal translucency. Okay, so after all that boring theoretical stuff, let's go ahead and take a look at a practical example in Unreal Engine 5. Okay, so let's go ahead and open up the Skin Master material. You're going to see that this material looks quite complex, but don't be afraid. Again, things are way easier than they look. In this case, we only have the base color connected to the base color, but multiplied by some parameters that are going to give it contrast and some other things. Forget about that, don't worry about that, just worry about the base color. Next, we have the normals, which again, don't worry about this, it just blends normals and roughness and controls the roughness, don't worry about it. And again, this is just a normal map, it's nothing new. We have the roughness map, nothing new either. Here we have something new. So this is called detail UV, and it's going to mimic the human skin pores. So we can take a look real quick here. We can preview this node so you see what is what. In this case, remember here we have Fresnel again. So you are seeing that it is appearing continuously. What does Fresnel do here? Well, it's quite simple. If we preview the node, you're going to see that it makes the pores head-on more defined, and it blurs them when you are looking at them from the edges. So you see that this is really simple. Nothing amazing here. Okay, so finally, we have what we have seen right now a couple of seconds ago. So the opacity map or thickness map. You can see that this is the map in which we tell Unreal Engine that some things have to scatter light and some others not. So again, let's see this in action in our level, and let's go ahead and take a look also at how we can select the subsurface profile materials. So if you go to the shading model, well, again, blend mode opaque, but shading model, subsurface profile. So in this case, if you choose subsurface profile, you are going to be able to use the subsurface profile here slot, in which you can choose different subsurface profiles. I have made one for human skin. Let me collapse this so it is not as big. There is no simple profile anymore. We just have barely in Unreal Engine 5. We have the surface albedo. This has to imitate the base color map. Again, the mean free path color is the epidermis, the inside of the skin color. So when the light penetrates, you are going to find this color. Like, for example, the muscles are more red and the epidermis is also more red. So you're going to find this. This mean free path distance is going to adjust the strength of the effect. World unit scale, I don't usually change this. The tint I do usually change if I want it to be more red or some other color. And again, the boundary color bleed is something similar to that. The other parameters, you can also play with them, but they are quite advanced. I may fiddle with the IOR parameter, but the others I usually don't have to touch. You can test them out. Okay, so first of all, before doing anything and testing anything, we need to go to the light sources, the spotlight, for example, that I have used, and activate in the advanced options of the light. We need to activate transmission. Why? You are going to see it real clearly right now. You can see that as soon as I activate the transmission in the backlight, you can see that the subsurface scattering starts working properly. Okay, so right now we have the subsurface profile working properly. You can see the surface albedo again, close to the base color. Here we have the mean free path color. You can see it right here in the backscattering of the ear. If I go and turn up or down the mean free path distance, you can see that it's going to affect the amount of light. And you can go ahead and see if I go 1, it scatters a lot of light, and I will keep it at 50% more or less, so 0.5, so that the effect is not too strong. The world unit scale, as I mentioned before, if you are using centimeters, so Unreal units, don't touch it. The tint, as you can see, you can fiddle with the tint on the scattering. Also for tinting is the boundary color bleed. I'm going to leave this to make the scattering more apparent. The boundary color bleed is for the transitions, and the transmission tint color is the base color of the transmission. So after calculating the subsurface scattering, it will be multiplied by this color, and you can see that it affects a lot the final result. So you have this to fiddle with also, so you can get the touch that you want. Again, we have the IOR. This would be the material IOR, and we can fiddle with the extinction scale to make it stronger or weaker, and the normal scale, so you can scatter in a different way. And I mean, these are fine-tuning parameters that you can try yourself and fiddle with, and you are going to see that they make a huge difference. Okay, so there is quite a cool trick, which is the lobe mix. If you turn it up, it's going to make the skin more matte, but if you go down, you're going to see the skin more greasy, and this can be quite awesome to dial in the subsurface scatter profile and make it really customized for our subject that we are trying to render faithfully. So I'm going to go back to the other because I think it looks good, but just bear in mind that you can fiddle with the lobe mix, which mixes the roughness 0 and roughness 1. So you could also make it more apparent and then go ahead and turn up or down the secondary roughness or not. Let's leave it at default, and you can see that the result is quite good because I am lighting right close up to the ear, so the subsurface scattering effect should be quite apparent. I also have a material instance here with the human skin material, so that you can adjust the, for example, the detail normals, the pore base weight, the pores, and so on and so forth. And I just think that it is not that complicated. You can fiddle with it with the other material, and you are going to see that you can fine-tune the look as you want. Oh, and by the way, you can find the subsurface profile in the material property overrides down here. It usually will be collapsed, but if you open it up, you are going to find the subsurface profile and also the shading model, by the way, which should be subsurface profile. Here I can switch between them if I want to. Okay, so let's now take a quick look at another material, another subsurface profile, which is the jade one. You can see that here I'm trying to get the jade look, and you can see the options, the different options that I have modified so that you can get that look. You can see that it now looks like jade instead of skin, and it looks quite awesome where the light is backscattering in the thinnest surfaces. I have also another marble subsurface profile and another marble material. Here you need a texture to create the marble feel apart from the subsurface profile, but you can see again that the look is quite cool and that we can get a customized look with just a couple of touches and a simple material. By the way, the material is really simple. It just has the textures with the marble tiling, and that's pretty much it. So you can see that it is quite a simple material. Again, you can see that you can get multiple looks really easily and with a photorealistic quality. So you can see that subsurface scattering in Unreal is really important, and it's especially important in character rendering. So I urge you to try it out and see the results that you can get with your characters. Well, so that has been it for this video. As you can see, translucency is a complex topic in Unreal Engine. You have to use it sparingly because it's quite expensive, and if you abuse it, you are going to get performance problems. You have seen thin translucent materials which are quite cool but are the most expensive ones, so be careful with them. If you found the video helpful, go ahead, like and subscribe. We'll see each other in the next videos.